help me with it because you've already had some training on communicating with the OBC. I want you to use your laptop and to talk to the OBC and to run the software on the OBC and allow us to use it to test the other subsystems. Okay, so the OBC, the ISIS OBC, will be powered from the serial 3 bus. We will use the UART interface and we will use the test software. The OBC will act as the master on the I2C control bus. On the OBC we have pull-up resistors and it will operate 7-bit address space and 100 kHz clock. We communicate with it using its internal UART, and eventually you can develop and test your own code for it. We will start with the demonstration code, and the demonstration code allows us to test the various subsystems. Okay, so that's what the OBC looks like. I think you have met it before. If you look at interfaces, at the very top of the screen we've got 2 connectors. So we had the question, what is this type of connector? Just quickly show this to you. I'm showing you connectors which you don't need to see. So this is the type of connectors, Samtec connectors. You get different prefixes because it's different series of connectors. SSQ, which tells you the series, ESQ and TSW. You will use them in different ways. So the EPS, for instance, didn't have pins sticking out at the bottom of a PCB. They will just go through a PCB. The gold-plated pins at the bottom is 2.4 millimeters long, just enough to go through a PCB. And then you get some which have got gold-plated pins sticking through the PCB, which allows you to stack. You get different types. You get with higher or with higher top, higher bottom, and this is one which is at the top, which doesn't have anything at the top of the PCB, but only pins at the bottom of the PCB. So depending on how you want to build up your stack, you use different connectors. They've all got a similar number. If you look at the first one is the series, SSQ, ESQ and TSW. Then the 1 to 6, the 26 is the number of pins in a row. And then you've got the second number there is 2 because it's a double connector. So it's 26 times 2 is 52. And if you've got 2 of these connectors next to each other, that gives you 104. The 1, the 3, the 8, all those are the length of the pins. So different connectors have got different lengths. They're all gold plated. That's the G. And the D at the end is double row. So it's a double row of connectors. So yeah, you can look at the data sheets. This is the connectors we typically use. By the time we build up the structure, we've already selected the connectors and we've populated the right ones on the boards. It's not impossible to change it afterwards, but it's much better to select the right connector at the beginning and solder it in. If you have to desolder on it and 4 pins, it's a lot of work and a lot of effort. But yeah, that's just to answer the question on the connectors.
เบอร์ 10 แล้วอุ่นแล้วเมื่อวานที่สุดเลย
Okay, so we're back to the OBC. And the interfaces, like I said, we start with the connectors. There's a few debug LEDs which are optional. There's a few optional connectors which are doesn't need to be placed. There's always a programming connector which you use to attach to the OBC to communicate with it over Eclipse, the software development IDE. There's always a daughter board connection. So the OBC is designed to work together with a daughter board. The daughter board is very similar to the IDIS. We've got some designs, but we have a special design for your mission. And I think it's still being populated as we speak. So we are going to not show you the daughter board in the training because they are still finalizing it. But it's not a problem, we can get around it, we can test a lot of things without it. This is the pin out, so you can see which of the 104 pins we use, and the ones which is not colored is actually not even in use. So that's why I say we are wasting a lot of the 104 pins. We can make our satellites much more complicated if we like. The physical interfaces we are going to be using is CubeSat Keepers connector. We use the UART and we do the programming and debugging like you have done already. And like I said, I want you to actually do that. So I want you to use your laptop and your software and say upload the test software to the OBC, allow us to test it. The interface on the software to test the OBC is very limited. You can basically see that it's there, but the moment we add subsystems, you can start doing more. Okay, this is what the setup will look like. We have a laptop with the Eclipse IDE. You have the libraries and the demo code running on the laptop or in the IDE. We will power it from the CubeSat Keepers EDSE, but not like this example directly from a power supply. In our case, we will power it when we switch on the EPS. So this is the same way as it would be done in the satellite. So when we switch on, we will power the EPS from external power, we will switch on the EPS, the kill switch, live switch, and then the OBC will be active, and then you should be able to see activity on your laptop screen to know that the OBC is actually working. You can use the I2C analyzer. It's sometimes useful if you have communication problems to see that there's some activity on the I2C bus, or alternatively not, or if you want to see problems on the I2C bus, then that's the way to see it. And use a power supply, use a multimeter. This is the test setup. So note that we will take away the connection to the EPS. We are not connected to the EPS anymore. We are now connecting to the UART, and the other connection to the EPS after the IOBC is actually going to be the programming connector. We are using programming connector now because every time we power it on we have to upload code to it. Eventually we will flash it, which means we upload the code to its flash memory, and that allows us to, every time it's switched on, to start running the right code. For the first start we'll do exactly the same that you've done in the training, to upload the code to it when we activate. The demo software we run over PuTTY, which is the same as what I've been doing. It allows us to control and send commands and to see activity on the bus. As you see, you can show if you want to. Okay, that's it. That's what I have for the IOBC. It's a very critical subsystem, but it's a short presentation. I think the reason is you've seen it before. I think it will take us a little bit more time to get going when we get to practical, so that's why I wanted to show you as well now, or to go to the antenna system, explain that to you, and then we go down and we do IOBC and antenna system together. Okay, any questions on IOBC? If you have, I'm not the expert, but I can get the experts in quite quickly. I always struggle to get Eclipse working, so I hope you understand it very well. But you had the training, I have not. So. Okay, let's go to antenna system. So you've got two antenna systems on your satellite. The first one is what we call the electrical version of the antenna system. We came up with the electrical version of the antenna system because we sold a lot of burn wires. And we had a lot of customers asking us, we bought burn wires from you last week and now we want to buy it again. And we couldn't understand why until we found out every time they switched on their satellites, they deployed the antennas. And every time they deployed the antennas, they had to refurbish the burn wires. And then we said, wait. We made a special version which simply, instead of burning through the elements, it has a small LED. And the LED powers on and it shows you, okay, now it's deploying. Once you have your code developed and your platform developed and you've got confidence, then you can go on and do a real deployment on the real wire. But for this, it's just a test. It's made to be electrically equivalent. So if the real satellite or the real antenna system draws a certain current, then this should draw about the same current. It's supposed to test the system. It's a dual redundant system, so I'll show you, but if you turn it around, you will see there's two microcontrollers. There's two of everything, two microcontrollers, two regulators. The idea is it's a very critical system, because if there's no deployment, then you basically don't have communication with your satellite. And there's a dual redundant system on the satellite to give you a little bit more protection against any problem. Then in the real antenna system there are deployment switches which tell you the state of deployment. For this one we have small jumpers, that red jumpers there. So basically when it's like that, it means it's all stowed, and the moment you pull one of the jumpers, it's the same as one of the doors went open, and the software should be able to tell that to you. So the deployment system, the OPC, is sending a command to burn, and then it's measuring the deployment system. And once it's told that it's deployed, the antenna is basically ready to do its job. From that time onwards, I like to think of the antenna system as a complicated temperature sensor, because once it's deployed, it will not go and roll itself up again. Then we only use the antenna system to monitor the temperature on the extremities of the satellite. So that's why I say it's an expensive temperature sensor. But to get to that point, of course, we have to we must have to put in all effort to make sure that we have successful deployment. And the electrical model is the tool to use to make sure of that. The antenna system is critical for the state control of the mission. So if you have a low voltage in your battery, you should not deploy before you've charged the battery. That's what happened with some of the QB50 satellites. And the thing to test that with is not a real antenna, but one with legs. The physical connector is Omnetics 9-way connector. It's an expensive connector, it's extremely small. You have to slowly and carefully attach it to the system. You'll see if you put it in skew, you can't just fully tighten one of the two fastener screws. You have to do half a turn. It's a small little difficult connector, but it's quite a high quality connector, and it's good enough to operate the satellite or the antenna system over, and it's exactly the same connector that's used on the flight model. So your IDIS is configured with two of these Omnetics 9-way connectors. You can see. Once we have it connected, it's powered from the EPS. So when we power the EPS, our antenna system should be powered if we connect the deployable power switch on the EGSE as well. And it's controlled by I2C from the IOBC. Telemetry, what we can get from this system we can see the temperatures, and that's the first telemetry to verify. And we should be able to get the switch status, in other words, which of the elements are deployed or not, which of the jumpers are there or not. The commands is something we have to be a little bit more careful of, because A, it will use a bit of current, and B, it will get a little bit warm. You can think that the antenna system is designed to burn through a little a piece of wire, Dyneema wire, so it is going to get warm. If you have your finger on there, you may get a little burn. It's not a big safety risk, but yeah, I don't want to be responsible for a blister on your finger. Then you first would arm it, and then you would do what we call an auto-deploy. Auto-deploy will simply go through all the elements and deploy them at the preset time. The deployment is done in such a way that you don't waste energy. So you can have a maximum burn time, but it will burn until it measures the deployment. So if you have a maximum burn time 10 seconds or 20 seconds, it will not burn for the full 20 seconds if it already sees the element is deployed after 1 second. I hope I can demonstrate that to you when we are busy with that. Okay, this is the test setup. So this will be the OBC together with the IDIS and the EPS, and then we'll have the two antenna systems, both of them connected with Magnetics 9-way connectors, and we will be communicating with the OBC, and we will be using the EGSE like we are doing normally. The one thing that's now new is that we will use the deployable power. Otherwise, the antenna system will not be powered, and that's just a safeguard to not accidentally power it. The functionality, if we go, sorry, now we're talking of the real antenna system. This is the flight model. I think we are at serial number 200 or something in the company. So we've been selling a lot of these things, and there's been a lot of them flying around. Yeah, it's a very, very simple electronic system. It's a medium complexity mechanical system. It's an extremely complicated RF system, and if you put all of that together, it's quite a difficult subsystem. So it's something that we've spent a lot of time and money on developing. You can do it yourself if you want to build a deployable antenna system for VHF, UHF frequencies on a nanosatellite, but we really think you shouldn't. We really think it's a lot of effort to get to this thing. So electronically, it's quite simple. It's powered from a 5-volt bus in your case. It's got a small standby current, which you will see the current increase from 20 milliamps a little bit when we add OBC and a little bit more when we add the antenna system. And then when you have a deployment, a burn, the current will increase even more for those few seconds that we have. Just like the ANSI-LEC, there are two redundant slave nodes on the I2C control bus, but the addresses are different. So if you think of the ANSI-LEC, it was address 31 and 32 hex, here is 33 and 34 hex. The reason for that is just that you have independent control of these 4 nodes. So with the two antenna systems, you actually add 4 slave nodes. After this next session, we should have 5 slave nodes and 1 master on the I2C bus. That's the EPS and 2 antenna systems, each with 2 controllers. That's 5 in total. The address is 7-bit, 100 kHz clock. You're able to do actual deployments of actual elements. I will not do that with your hardware. I will only monitor the state of deployment, and I will only monitor the temperature. If we want to do deployments, we will rather do it with the ANSI-LEC. But in essence, it's the same thing. You can burn through a LED, or you can burn a LED, or you can burn through a wire in exactly the same way. The current should be basically the same. Only difference is, when you switch off the LED, it's off. When you switch off the antenna system, the element is outside. So here we have the interfaces, physical is exactly the same as with the ANSI leg, but we also have an RF radio frequency interface. This is where I think this becomes a complicated system, because if you think of VHF and UHF frequencies, the wavelengths involved is bigger than the size of the satellite. UHF is operating in about 70 centimeter wavelength, and VHF is operating in 2 meter wavelength. And we have an antenna system on a satellite which is much smaller than that. And that complicates the RF design quite a bit. So what complicates it is that if you think of the antenna, one half of it is this element deploying, and the other half of it is actually the structure. I will not go into all the theory, but basically the structure and the element are both resonating at the frequency you want it to. In practice, what it means is if you change the structure, you also change the antenna. So if you have a deployable solar panel on your structure, the antenna changes. And this is not so intuitive, this doesn't sound logical. Some of the clients buy an antenna from us and we tune it to a certain structure, and then they change the structure, don't tell us, and then the antenna doesn't work. But it's because the structure is actually part of the antenna system.
What you saying? Before they buy your antenna, they have to tell you how the structure of the satellite
Exactly.
would be like, and then what the frequency they're going to use.
Exactly.
Okay.
So what we typically ask of our clients when they buy an antenna is we ask what is the size of the structure. If they tell us it's a 1U satellite, we have a model of a 1U satellite in our lab. And before we ship the antenna, we tune it to the right frequency and the right RF behavior on that 1U structure. But if they tell us it's a 1U structure and they actually have a 6U with deployable antennas, solar panels, then the antenna won't work. And it's very problematic now if you come to deployable solar panels, because deployable solar panels change the size and the shape of the structure quite a bit. So we have some idea of how the solar panels will look, but some customers have got a very complicated solar panel. We actually have to make a model of the solar panel before we can sell them an antenna. We have to just keep that in mind. That's why the big difference between the antenna elec and the real antenna is the RF interface. And the RF interface has got links to the structure as well. So your system is relatively simple. It's a 6U structure without deployables. That means we tuned it to that. It's not so difficult. But if you have a flight model with appendages, big sensors or deployable solar panels, we have to keep it in mind. Okay, we tune it to free space. We have to tune it on a structure. Free space is also a difficult concept because free space is actually if the satellite is in orbit. But we can't put the satellite in orbit to tune the frequencies. We don't have ladders that's long enough. So we create free space by taking an open area. We have a special room without lots of furniture in there. We have a cable going to our equipment underneath the floor or outside of the room. And then we do a tuning without a person in the room. Any person walking around changes the tuning. Any furniture changes the tuning. A big piece of metal in the roof or in the floor changes the tuning. So VHF, UHF, free space tuning, quite a nice little challenge, and it was especially difficult to get the first one done. We spent quite a lot of hours to tune the antennas before we shipped them. And that's also why some people will say, oh, this is such a simple thing, it's just an element, just a piece of wire. Yeah, but it needs to be resonant at the right frequency. We make a lot of problems for ourselves. We also do some some analysis or some simulation beforehand. We've got some expensive software packages which allows us to generate this type of diagram. This is a radiation pattern diagram. So it shows you with this antenna on this satellite structure, where will you have the biggest gain and where will you have less gain. That means if you have a satellite that's tumbling, you can overlay that diagram in your ground station and you can understand why sometimes the signal is strong and sometimes the signal is weak. It's actually very logical. So if this is my antenna, it will generate a pattern which looks very much like a donut. So if I have it upright like this, you can imagine a donut-shaped radiation pattern around it. And if the ground station is the camera at the back, the maximum gain is actually looking directly at that camera, and I will have nice, good communication. If I rotate this and it looks like this, then the hole in the donut is looking at the camera. That hole is an area where the radiation, the gain is the least. So now the signal will be quite bad. Okay? And if you think of a tumbling satellite, then the hole will be looking at the ground station and not looking at the ground station, looking towards and looking backwards. And that's why if you have communication in your ground station, sometimes you have a good signal and sometimes you have a bad signal. And those two cases can change quite rapidly. So that's just from the antenna theory. Okay, but that's for later. That's a worry for in your ground station. That's a worry for operations. When we work in the engineering model, the antenna looks like that all the time, and the ground station looks like that all the time, and we've got good communication all the time. Yeah, the other interface is power telemetry. Exactly the same. With the only difference now is I will not really do deployments. I don't want to do refurbishments. Refurbishments is something which takes a bit of time and effort. We've got some very good engineers who are very experienced in that. That's not me. To refurbish these antennas is similar. I don't know if you've seen fly fishermen. Fly fishermen like to make their own little bait. They tie strings around feathers. They have very small loops of wire and they make very fine pieces of bait. That's what it's like to do the refurbishment on an antenna system. I'm not a fly fisherman, I'm not so good with that. My fingers are too big. Okay, functionality, very similar. 5 volt, 5 volt bus, 8 milliampere standby, we'll measure that now, 2 slave nodes. You can do actual deployment and you can actually see the deployment. You can monitor the telemetry to see the state of the deployment source. Okay, that's it for the theory session. I suggest we go downstairs again. So then downstairs we want to look at the IOBC and the antenna systems. Okay. And you've got the Eclipse set up on your laptop? You must try.
อาทิตย์หน้าต่อ
อันนี้หัวเพี้ยน
ต่อให้ปุ้ยอยู่นะ
ได้หรอพี่ผมรักครอบครัวเนี่ย
วันนั้นเห็นพูดอย่างนี้เนี่ย
ฮะไอพี่
ไรดาวทำเลย
เป้ไปทำอะไรเนี่ย
เราทำเลยต่ออีกต้องใช้เหรอเพราะว่ามันจะให้เราบอกว่า
I want to do I want to do the UART on my side and the Eclipse on your side. Is that okay?
Okay.
Okay.
So I need another USB, right?
Okay, yeah, let's do it like that. It's safer. So then you do the UART as well. You do the control and the
Monitoring.
monitoring.
Okay.
IOBC. This is the main processor. This is the connector for the daughter board. And this is the programming interface which we will be using. How can I show you? There's some debug LEDs at the bottom there which shows you the state. And you can see data coming and going, but that I think you've seen in your previous training as well. At the bottom, this is flash memory, which you can use to program to upload code. And this is SD cards, which you can also use in flight. I think you actually have some SD cards delivered with it, which is not such a big SD card, but it's one that we know actually works well in space. That's about what I can show you. For your mission, there's a special daughter board being built, but I don't have it unfortunately yet. The role of the daughter board is going to be twofold. The one is to interface to the sensors on the solar panels. So there will be 6 wire harnesses coming from the solar panels to the daughter board. And the second is to be the interface to the Gecko, to the payload, to the camera. So the interface is going directly from the camera mass memory to the IOBC, and the IOBC has got the interface to the S-band transmitter. That's just how we're going to use it. Okay, so next step is let's supply it with a connection here. Let's see how I plan to do this. This is my procedure.
TX ได้ไหมหรอไม่รู้เขาจะให้รันตัวไหน EPS ป่ะ
It's a little bit stiff, these wires.
เปิดแมนนวลแล้วไม่จะให้เขาที่ยิงเอ็นด่าเขาแน่เลยก่อนขึ้นไปเขาเปิดแมนนวลทางโน้น
Are you wearing your ESD strap?
Yeah.
Oh, good. It's not so important.
What if I say no?
Then I'm just seeing if your colleagues are aware. I'm testing you.
เป็นไรครับปรับเพิ่มขึ้นแล้วเนี่ยเท่าไหร่เขาเก่าไว้ทั้งหมดแล้วไหม
So in the IDE you have connection to the SAM.
Wait a second.
Could not connect to target.
Okay, the
Yes.
target is not there yet.
It's not on.
Yes, but this is on. You can see the program.
Push not.
ขยับอยู่ USB นะ
Yeah, you should also open up a terminal window, PATI or something.
Yeah.
Okay, that's done, and it's at 2 megabits per second.
พอเช็คได้
เช็คแล้วไม่ใช่แล้วเลย
ปิดเปิดไหน
มันไม่เกี่ยวกับพาร์ตี้อะพี่ มัน
ปิดอีกคลิป
ปิดแล้วเปิดใหม่ครับ
ใช่ใช่
มันไม่เกี่ยวกับพาร์ตี้อะ
ไม่เป็นไร everything
What's this?
so by restart
The basic one, right? If you don't know anything, just restart it.
Yeah, even with MacBook,
all satellite
all satellite, that's not so easy. I told you the ladder is not.
Yeah.
No,
Oh, I
it
know.
doesn't work.
It's okay?
Sam I found อ๋อ
It said
Sam I
could not
found
connect to target.
You must just see that there's a certain serial number here.
version 8
To
Sam I found serial number 2802114
That-
Yeah.
that's correct one.
Yeah.
feature checking target voltage shutting down
Okay, but the target is not there
Yeah,
because
yeah.
it's not on.
okay
Let's switch it on and
Okay.
then we try again.
okay
Okay, so I'm going to operate off external power. which is
Yep.
this guy.
7.5 volt.
Yeah, which is safe. I will leave the battery disconnected. You can see the battery is off, but it's not. My EPS EGSE is not on. That must be on, otherwise that will never go on. So it's on. Battery is disconnected, and if I now switch this on, I expect the 3 LEDs to go on. But that will only happen if my power is on. So now the power is on. The current is 0.
Yep.
If I now switch on kill switch, I expect those to go on, and now it is.
Yep.
Okay. Current is more than before, because we've added OBC. OBC is active, as you can see, with the red light. Now it's your turn.
Yeah.
Yep.
Okay, good. So if you go to,
So which one you want to run?
I want to run the demonstration.
It's
Satellite demonstration.
it's
or
have a lot of-
LVC.
Yeah.
OBC.
And then I should.
Which one? I don't know. You have like OBC. Is it to blink the LED on the OBC?
No,
So this
no,
one?
not the light.
But you see it is like a lot of.
Subsystem demos.
Yeah,
No, I want the main demo code.
main.
Yeah. It's a demonstration of that one at the bottom, just one down. That below that one, yeah, that one.
This one? This one?
Okay.
This-
So if you can program it with that one, please.
This one? You want me to run this one?
Yes.
Not lunch. It run ได้เหรอ
Well, there's a small.
It can be run. It can debug.
Now, if you go there, yeah. So, hell. The subsystems demo, number 3, yeah. Okay. Now it's building. Now see it's launching. I expect that to increase slowly, and now if you go to, yeah, there. Good. No, that's still the bootloader. Here you should see a menu with 1 to 8 and all the subsystems listed.
Why is so slow today?
I don't know.
Last time it's a lot quicker.
It's not enough
Yeah.
coffee.
It's a lot quicker หรือว่ามันคอมไพล์ไว้ก่อนแล้ว
Maybe.
Okay, there's some change now.
Yep.
มาแล้ว
Yes.
โอเค
Looks good.
หมอนี่แหละแรกที่สุด
So just give it some time. It's MacBook. Just be patient. I don't know. I've never had a MacBook, so I
That
don't.
one Dell or HP.
I'm sorry?
Dell or HP.
Dell. I like Dell. I've got some respect for Dell. Okay, so now you can see the various subsystems. Sorry, I can't really see the screen so well.
Because MacBook.
Yeah, it's too shiny. Okay, so there's no real test to show us
The
IOBC itself. But we have tested the IOBC setup because we are able to connect to it. We are able to compile to it. So actually we have tested the IOBC quite a bit. And you can see the current increased quite a bit. But there's one other subsystem which we can test now. Which one is that?
TX antenna deploy
No.
TX.
TX
This guy.
EPS
EPS. Yes. So will you please go to number 10? Yes. Okay. So press 1. This is housekeeping. Now give us a screen. Okay. Now
it's coming here.
Now suddenly we see data from the EPS.
Yes, good.
Okay. This is a big milestone in our process because for the first time we've done integration. we've taken two things and we've tested them together. The first, well, we've done it a little bit with IGES and EPS, but that was boring. Now we actually have IOBC. We've got software working together with two pieces of hardware, lots of code. This is a big milestone. Don't underestimate the complexity behind all of this. Okay, what can you learn from that telemetry?
The input voltage from solar panel.
Yes, that's quite low.
Yeah, and current from them.
Yeah, also very low. It's
And
negligible.
the current battery voltage.
7.5.
Yeah.
Why there is a voltage coming from the solar panel?
That's noise. There's no voltage connected to the solar.
Yes.
That's just noise. That's why I say actually negligible.
And the whole system.
Where is this one attached to anything?
No.
This is the
This
UR.
one?
Okay, it's not attached. So I just want to pull it out because we don't need it anymore.
Okay. So I have to run again because.
Yeah, you can. Why not?
Doesn't matter.
So just number 1 again. Okay. So if you think of the pilot, that's the instrument. And this is the airplane, and we are flying using our instruments. So you must get familiar with those values and get to trust them a little bit. Now we can still compare the current there with the current here, and the voltage there with the voltage here. But eventually we will lose this, and we will only have that. So yeah, it's a this is the type of thing you must get familiar with when you work with the satellite on your own.
What is the PPT?
The PPT mode is the mode of the solar panel, the solar converters.
Peak power.
I think that's MPPT mode, but I think if I remember correctly, mode number 3 is still the fixed voltage mode. But it's not, it's getting power directly from the power supply, it's not getting power from a solar panel at this stage, so it doesn't matter. Something else I noticed there which is interesting, the boot counter,
49.
49 now, so it rebooted once, we powered it on once.
Yeah.
Okay, okay, just look at the next one. The output power, or the output switches are all off, which is good, we want it like that. If you look at the menu, there's another thing you can ask from it. Housekeeping number 2. I'm not sure exactly what that is. Okay, more information. So it gives you more detailed information. I'm not going to go into the detail of that, that will be in the user manual. But
What did HK stand for?
housekeeping.
Okay.
Housekeeping.
I shouldn't ask.
Headquarters.
They wrote by Hong Kong.
Hong Kong? I don't know.
Yeah, I'm thinking about
for
shopping in
Hong
Hong Kong.
Can't be too much. Okay, what is the next one? Watchdog timer. It's just, watchdogs are measured to protect the satellite and keep it active. Wait.
Oh, wait. Yeah.
Can you just pass me the box which says IGES, yes.
ISIS.
IGES. Yeah,
IGES.
IGES.
Yes.
London.
Sure.
London.
Okay, so what we have here is a small little EGSE board. We call it the flame board, because it's got a lot of little LEDs on it, and it allows us to see all the channels, the activity on the various channels.
Yeah.
So 3 of those will be the same as those 3, but then it also shows us the state of the switch channels, and you actually now have control over the switch channels. So if I press this in, I expect 3 channels to light up, and then when you switch on one by one the channels, I expect them to be switched on here as well. And one of those or 2 of those are our ADCS. This is how you will switch on the ADCS or the camera eventually. Okay, so let me just...
Excuse me, what does it mean by now, like when I put the air inside, enable channel?
Yes, you are able...
It means enable What kind of
power
data?
chain, power channel, because
Oh.
you've got 6 switch lines,
Mm-hmm.
and you are able to enable each of those 6 lines individually. Okay, so I will just very carefully attach this here. Okay, 3 lights are on, bad bus, 5 volt and 3 volt 3 are all on. What I want to ask you now, okay, so you also see a small increase in current. So if you request current now,
Number 8.
number 8,
Select channel to enable.
okay, which one? Try 0. Yes, 1.
1. Oh, sorry.
No, don't kill it. That's the kill switch.
Boom.
8.
8 and then 1.
1.
Yes. 8
And then 2.
and then 2. Yes. 8,
And then
3. Yes. 8, 4. 8. Okay. Now you switch on all 6 output channels.
That means your LED working.
Your
LED working.
The LED is working.
Good.
For now that's a bit boring, but eventually it will mean the ADCS is on.
Yep. Okay.
Or it will mean the payload is on. Or it will mean whatever system
So-
you've worked on is on.
For the ADCS, how many channel that it use?
It uses 5 volt 1 and 3 volt 3 1. So you have to switch on both 5 volt and 3 volt 3 to activate the ADCS.
And camera use another two.
I'm not sure. I'm not 100% sure. I think the camera actually uses a switch on the door to board.
Oh,
So the camera is switched on directly from the IOBC.
oh, สีเขียว
Okay. So good news, you have got control over the IOBC, even with a MacBook, and you can switch on all the switches. Okay, can you
Disable.
switch? Disable, yeah. Please. The LEDs are 5 volt are yellow, and 3 volt 3 is green, and red is battery bus. It's got some color scheme to it.
Can we turn on all the channel at the same time?
Yes,
Turn off and
you
turn
can,
on.
but probably not with the demo code.
Okay.
But there is a way to turn it on.
Yeah.
There's also a way to turn it off. They're all off now. There's a way to turn it off with a delay command. You can also, one thing that's quite complicated is you can specify their state dependent on the battery voltage. So you can say if the battery is in normal mode, this is what the state should be of the switches, and if the battery is in critical mode or safe mode, this is what the state of the switches should be. That becomes very complicated,
Yep.
and it can mean that you have a system switching on and switching off when you don't expect it. Again, something which happened to the QB50 teams, a satellite which was operating normally, and then suddenly after the battery became drained, without them expecting it, started switching something on or switching something off. And it was because they didn't understand the setup well enough and didn't prepare the setup well enough. So it can go wrong and can be too complicated. It's good to test it beforehand.
Yep.
Okay, so we have tested the IOBC and we've verified that we can communicate with the EPS, which is a big milestone. But let's do the antenna system now. Okay. So if you can just hand me
วางไว้ที่เดิม But it's still under your responsibility.
This is a very big question. I don't know.
It's
I'm-
recorded.
I'm not in control. Oh, this is why the camera is here. I will say you edited the video. Didn't really happen. No. If I make a mistake, it's a mistake. Okay. So now, this is the ANSI-LEC. Yeah, we've just completed a slightly newer version of this one. So this is the older version of the ANSI-LEC. If you look on the board, you can see Ref B. But something I'm very proud of, if you look on the name.
You name on it?
Yes.
Really?
Yeah.
Wow.
Yeah. Also on the Aegis and also on the
How's your name?
Which one is your name?
second one, JE.
Oh, JE.
Wow.
Yeah.
And you said that your hand is too big for this one.
Yes,
it
it
has.
is. Can you see? So yeah, with the new version, we will lose the name,
Oh,
which
that's
is
so
a bit sad, but okay. At least the design is still similar. So there's the LEDs. You will notice that there are 8 LEDs, and if you think about the elements, there are 4 elements. The reason that there are 8 is that it's a dual redundant system. So for each door, there are 2 burn wires, or 2 chances to burn, but there are only 1 switch. So this is door 1 switch and burn indicators for 2, 3, 4. And if we pull this, we can see the change in state. On the top, there's not a lot of things to see. This is the programming connectors. This is some external connections, which we will not be using right now. On the bottom, this is what it looks like. So first thing you notice is the Omnetics connector. I told you this is a very expensive, fancy, challenging, small connector. This is the connector on the IGES side. So you made it in there. You can also see some symmetry. So this is the microcontroller. There's another microcontroller. This is power regulator. There's another power regulator. This is switch. There's another switch. Oh, sorry. This is I2C interface. There are 2 of them. This is the switches. Double. So this is a fully redundant system. It's, if you lose one half of the system, the other half can still do all the functionality. Typically, after deployment, you are not worried about it, but before deployment, it's a good insurance policy to have. Okay, let's demonstrate this guy then. I very quickly just want to check, because we've got two connectors. I don't think it makes a difference which one we use, but I just want to verify really quickly, because I'm not 100% sure. So I've got the production instruction. Here's the IGES, which is a big document. The ANSI-LEC is the top one, it's this one. The normal ANS is the bottom one, is that one. Okay. I'm only going to do the ANSI-LEC for now. You'll see the interface behaves exactly the same, so there's no real reason to worry about the other one. Maybe before we do that, can you hand me the ANS? I'll just quickly show it to you as well. ANS, yeah, that one. Perfect. So this is a cable, an RF cable. So if you connect it to the radio, this is what you will use. 2 of them, because you've got 2. Well, this is the connection. This is the connection cable. You actually get a spare one. So you have one already integrated in the IGES, but you get another one of this expensive connectors. I won't say for free, but it's included. It's included. This is a refurbished kit. So if you would do a deployment with your antenna system, you can refurbish it yourself. In the user manual there is a procedure on how to do it. If you want to be the fly fisherman, you can do it. Sorry?
It's already included.
It's included with your antenna. You already paid for it.
How many sets that we get?
I think 2.
Only 2?
Yeah.
How expensive?
No, it's not very expensive. The time to do it properly is more expensive, I think.
No, I mean like the wire.
No, the wire is very cheap.
It's very cheap, so it's quite easy to
Well,
order.
what we basically do is we tie the knots already.
Okay.
And that's what's expensive, not the wire.
Oh.
The time to do it is expensive, not the wire.
Okay. Okay.
So this is your antenna system. This is the flight model of your antenna system, or the real antenna system. If you look at it from the outside, it's just an aluminium plate. But I've shown you in the presentation, underneath it there are 3
Yep.
holes. And in the holes there's like a spring element coiled up. This is held in place by a door. So there are 4 doors. And there. And the door is held in position by a small piece of wire. That green wire is running along there, and it's running over a burn resistor. The burn resistor is similar to those ones, and they actually get hot when you pulse current through them, and they burn through that green wire. Once that it burns through, the door opens and the element comes out. So 2 of them are short elements, about this long. 2 of them are longer elements, about this long. The longer elements is the VHF dipole, or the elements of the VHF dipole. The shorter ones are the UHF dipole. The VHF dipole, if you do it on the ground, it droops. It's not stiff. The UHF is stiff enough to stay straight, but in space, because of weightlessness, it doesn't matter. On the ground, it looks as if it will never work, but in space, it actually works. What more can I show you? So there is the connectors. Oh, this is actually a different type of. There's only one RF connector. I think it's a turnstile. Yeah. So anyway, there's the connector. This is the phasing network to get the RF characteristics right. There are the 4 elements. They are labeled. You can see it on the PCB. This is the same microcontroller that's on there. That's the same switch that you have on there. That's the same I2C interface that you have on there, and that's the same connector that you have on there. So this is electrically the same thing, but in terms of RF it's not the same thing, it's different. In terms of what the OBC will see, this is the same thing. It's exactly the same thing. What more can I tell you? Oh, you see there's a small little corner there, that triangle. This is to make it compatible with a competitor structure. So if we have to mount it on one of our competitor structure, you will actually break off those small triangles. But because you choose the good structure, you don't need it. Those pads over there is the programming connector. So we put on a programmer, program it, and take it off again. This is serial number. I don't know exactly, but it's revision D, and it's been it's the 4th version of the system, and we've done about 200 of them already. Okay, that's what I will show you with the antenna system. For testing it electrically, I think we should play with the electrical one. Eventually, once you have your satellite, maybe it will be an interesting test to plan and execute a deployment test of your real antenna system. I think that will be quite a milestone.
เอาไปเทสให้ผบดูก่อน
เขาใส่ไม่ได้
เขาใส่ไม่ได้
Okay, if you can just put it back there. Right, so this is my connector. So normally I would power down the system at this stage and then integrate and test it on again.
Normally.
But for now, because it's an external system, or it's powered from external power, it will only be powered when you switch this on. I think I can just integrate it. It should not be a problem.
You think so?
I think so.
ไม่งั้นมีกองเชียร์
Where's the camera?
กองเชียร์เขาแช่งอยู่กองเชียร์เขาแช่งอยู่เรียบร้อยเขาไม่ต้องก
ตัว
ด
นี้มันแค่ LED สว่างเฉย
ใช่เบอร์นี้ไว้
กันเหมือนกับ
IOPC มันใช้3 โวลต์นะ
Okay, so I told you this is a very fine and very small connector. So it's 9 wires, the same as a DB9 connector. Very small, very light, very expensive, good current carrying capacity, and you can see the way it's been processed, the wires. This is done for EMC, so it's braided and it's done in a way that this is not generating noise and it's not picking up noise. We can make it a little bit longer, but then you can start getting problems. If you have a 6U satellite, this still works fine. But from experience, this is the best way we can process it. Can you just hand me that small screwdriver there, please? Thank you very much. So what I have to do now is I have to attach it over there. There are 2 screws, and the problem with this thing is mechanically the tolerances are very, very small, very fine. So I can't tighten the right hand side all the way and then do the left hand side, because if I do that it goes skew. So what I have to do is I have to do 1 turn right, 1 turn left, 1 turn right, 1 turn left. The other thing you have to notice that if you look from this side, there's a little cutout. So I have to align that cutout with the cutout in the connector. Okay, so it's flat at the bottom, the
อัน
cutout
นี้
is
ผม
at
ยัง
the
มองไม่
top.
เห็นเลย
ต้องใช้ใส่กล่องคัดเอาท์ใหญ่มากเลยนะอ๋อyou make 2 turn already
More than 1 turn. I mean, the first turn is easy.
too many turn
You're counting.
Yeah.
You're a difficult
We have to
student.
make
We
sure.
record.
This is
camera
even
on
worse.
youอะ
So the team asked me if I wanted 2 tools, then they do 2 both at the same time.
แต่มันก็ดีคือแบบ
ใช่
มันเอียงได้ไม่ต้องทุบ
I have to do this because it's a bit skew.
มันผมว่ามันคงเผื่อไปอยู่ส่วนอื่นต้องแข็งหน่อยใช้หัวแบบนี้ตัวที่เหลือเป็นแบบเสียบอันนี้ล็อกด้วย
ช่างของผมต้องเรียกว่าซากุไลงงมาก
ไดเวอร์ยัง
ซากุไลครับซากุไลครับหัวหน้าอะไรคือซากุไลมาจากสกูไดเวอร์ที่ฝรั่งมาเรียกคนไทยก็จะเรียกสกูไดเวอร์ออกเสียงไม่ได้ก็เรียกได้แค่ซากุไลซากุไลช่างแก่ๆเรียกซากุไลทุกคน
แต่เขาไม่เรียกไข่ควง
ไม่เรียกไข่ควงนี่ซากุไล
ถ้าไมโครแสดงว่า
ผมเบิกสกุไลครับอะไรคือสกุไลแบบงงมากเปิดติ๊กก็ไม่เจอ
ทำไมไม่เรียกไข่ควง
มันเป็นศัพท์ทางเทคนิคครับ
เฮ้ย
แสดงความเป็นตรง
ทับศัพท์สิสกุไลสกุไล
ถ้าบอกว่าไข่ควง
นึกว่าซามูไร
ไม่ได้ทางนี้เป็นรุ่นใหญ่
นี่สนใจคุณเรียกสกุไล
จะเป็นเสียงแปะๆบ่อยมากแปะๆมาจากไอ้ตัว
I think my tool is not in such a good shape because it's also
I heard some clicking noise
some crack
some cracking noise.
I'm pretty sure you broke something
กดดันเอา
Now I'm sweating.
มันจะพังเพราะว่าเราเชียร์แช่งอยู่จ้อง
ได้แล้ว
งานละเอียดมากนะมีการมองเห็นไหมนะถ้าอย่างเงี้ยเห็นอยู่นะ
ใครทำครับต้องไปซื้อกล้องมาให้นะ
Okay.
มันขยาย
เสิร์ฟที่เขา
So now it's integrated.
Yep.
Current is still about the same.
Yes.
So we didn't change anything. No, it's on all the time.
Oh, okay.
I left it on. But if you try and communicate with the Anselec,
5
yeah,
And test
and now ask for telemetry, temperature telemetry,
5
telemetry,
4
yeah, 4 and 5. Okay, nothing.
190 degrees Celsius
Crazy temperature.
Yep.
Yeah.
Too hot
5
Okay. So what I'm going to do next is I'm going to power the external power, and then you should see a small change in current. There you go.
Yes
Try again.
5
Mm-hmm.
26. Oh, okay.
Oh, okay, that's
Good.
more. That makes sense. Okay, so
มีอะไรเปลี่ยนไปอีก
มันออนแล้วพี่
แอมป์เพิ่มมา 0.13 แอมป์
also the
milliamp
same for the other one.
แล้วก็
Yeah, same.
อุณหภูมิ
So I'm just-
เมื่อกี้หาเซนเซอร์ได้ 190 อันนี้เหลือ 26
I'm just seeing if I'm too stressed out. I'm touching them with my. Do you see a change?
What?
If you ask temperature again.
โอเค
shoot hotter
Yep.
อ๋อกดไว้
shoot hotter
27.
28.
No, I'm still alive. That's it. Let's go. Let's go and play with the video.
ไหน
A lot of work as well.
and you have two antenna connector
Yes. So one is for receive and one is for transmit. Okay, so for this test, I think I will connect it at the bottom there. But let me just quickly get some test RF cables. I need to connect that before we start communicating. At the same time, let me also quickly see if my interface works. Otherwise, I need Marco anyway.
เช็คของผม
ใช่ เป็นกับ station simulator
Access of this
seem to work
You are too optimistic.
seem to
connect
doesn't mean it work
Oh, you didn't even get that far. Let's just see. It takes a while. There's a lot of things happening in the background, so you must remember this is a software-defined radio.
ไม่เวิร์กแล้ว
So
ไม่เวิร์ก
กด
แส
ห
ด
น้าง
ว่า
ต่าง
นี้
ไม่
ไม่เวิร์ก
เวิร์กแล้วเนี่ย
it means there's a lot of software running, and it's
แสดงว่า
my
ไม่
poor
เวิร์กแล้ว
laptop
พี่
is working
เดิน
very
หน้าต่าง
hard
เมื่อกี้ไม่เวิร์กแล้ว
to work with this.
it's not working you got to call Marco I saw the I
We
call
have-
it magic
we have the
Windows
same
already,
area.
so-
If you have
as
errors,
you see there
then you're worried, right?
yeah
No, it's still
It's still not okay you optimistic
too optimistic. I want to get this working before I start working with that. And that's a very big rule of integration. If you don't trust your instrument, if you don't trust your test equipment, don't go ahead and debug or
okay
otherwise you've got two unknowns and you don't know if something is wrong, what's wrong.
สรุปมันเวิร์ก
And normally we're in too much
กูว่า
of
มัน
our
เริ่ม
own
ก็ไม่เวิร์กอยู่ดี
นี่
to
Windows
do things at the same
Windows
time.
Are you using Windows
Windows
7
10
or
7, yeah.
อ๋อเซเว่นเหรอ
ไม่เวิร์ก
32 bit or 64 bit
64.
64
Yeah. But it, I know it
Well, I hope
did
it
work
will
before,
work.
so at least.
ไม่ได้เวิร์ก
oh okay
But what changed in the meantime was there was some update in Java. There you go.
มาแล้ว
good
Okay. So I've got a very simple trick. I want to test if I can actually communicate with this thing. So what I do is I send a packet on an uplink, and I receive on 3 times the harmonic, and then I test. I send a packet from my transmit port to my receive port, without this being in the loop at all. If that works, then I know at least this part of the setup is working. So to do that, my downlink, I will send the command at 145. I will send it at BPSK. I will send it at 1K2. And
มันไม่ใส่เสา
the
งาม
downlink is
มันไม่ทำร้าย
445. That's 3
What?
times.
One A,
Exactly
one
3 times.
ไม่ถ้าใส่มันจะแรงเกิน
That frequency.
อ๋อหมายถึงสะท้อนกลับใช่ไหม
That means that if I send at that frequency,
ตัวไหน
มันไม่พังแล้วนี่
the third harmonic is
TX
exactly
มัน
at
ต้อง
that
ใส่
frequency.
อ้าวเขาไม่ใส่พี่
นั่นไงมันใส่ไง
ใส่ alternator
แอทเทนนี่ถือว่าเป็นแอทเทนห้า
If I go
ไม่
to
ไม่
the
ไม่เป็น
TV
แอท
terminal,
เทนไงมันยังไม่ออกมา
หมายถึงไม่ใส่เสา มันไม่สะท้อนกลับเอา
ฟอนต์เอ็นไม่พังครับ
มันน่าจะเป็นโหลดอยู่โหลดหนึ่งเหมือนกันนะ
เพราะมันถ้าเราไม่ใส่เหมือนมันส่งไปมันเด้งกลับ
มันเป็นโหลดอยู่โหลดหนึ่ง
This
แล้ว
frequency can switch.
Yes. No, sorry, you can't. No, the frequency you can't switch, because I'm just using the third harmonic. So if I change the frequencies, then it won't work. So, yeah, I want to send it a little bit more so that you can actually see what I'm doing. I want to repeat it 10 times. I'm going to send it, and while it's doing
แล้ว
that,
power ไหม
there you see the frequency,
ใช้เติร์ดฮาร์โมนิกใน
and
การ
then
เซ็น
it's done. Okay. Let me just move this down a little bit. But you know all of this because you've seen this before. Not? Or not the trick. So now I've received 11 packets.
But you said you sent 10.
Because I sent one
Oh, okay.
and then 10.
Yep.
1 plus 10.
Thank you. 1 part 10. 1 part 10
No
equals
problem.
11.
So that's what the signal looks like. Okay, so you see the frames, the flags,
Yeah.
the data, flags, data, flags, data. This is what we expect our radio to show us as well. So we expect to send a command, then receive a command. When we receive a command, we should see the flags because it's going to look the same. So at least I know this guy is working. If I have my frequency set up correctly and I have this guy working correctly, then I should be able to communicate to you. Okay, I will be gone for a short while. I just want to get a cable for this guy to connect to him. I'll be with you just now.
มีนิ่งว่าอย่าไปแตะอะไรของมันใช่ไหม
ห้าม
มันดูดแบ็กได้ด้วยเจ๋งดีครับ มันดูดแบ็กส่งกลับมาจะ
This one,
Yes, yes.
that is receive, and the bottom one is transmit.
Yep.
And I will just wait for the RF cables and then we can continue. But for the meantime, I can at least put it in the connector.
แล้วมันก็เลยใส่ใส่ประเทศมา
So the RF cable didn't come out.
Marco is
เวลา
bringing
ต่อมันไม่ค่อยแบบเข้มแข็งแรงไงพี่ถ้าปัดอะไรโดนหน่อยมันก็
อืม
มันต้องเป็นไงถึงจะดี
ต้องเป็นแท่น
ของเป็นแท่นจับเนี่ย
อันนี้มันแบบเหมือนวางที่พื้น
มันมีใครสักคน
ถ้า
ต้นโหล
ผ
ด
มว่าต้องมีใครรับผิดชอบสักคน
ถ้าไปโดนโลหะอะไรข้างล่าง
warning me.
no
Why not? You should.
dust cone
Sorry? That's there. Good. Now you're doing it.
แบบโคตรเลย
แต่เขาแบบคล่องใน dust เต็มตัวก็ตก
ระหว่างตั้งใจเรียน
Okay, so let's maybe get our OBC working first.
เกิดแค่ผู้นำไล่ลงไปก็เยอะไม่ต้องอวดดาสตาร์มา
So I told you I'm a little bit worried about the current limit because the current when we start transmitting will be 400 milliamps more than now, or than without it. So maybe let's just increase the current a little bit.
Hey, Joe.
Hey Marco.
What is exactly what you need?
I've got the T-Rex VU now,
Yeah.
and I want to test it.
Yeah.
But I don't have test cables.
Okay, but you just want a loose cable with the load. That's
I
it.
want the load attached to the transmit port, and I want
Yes.
the test antenna attached to
the receiver.
the receive one.
Okay, let me see what I can
But
get. for you.
I don't have anything, or if there is something in the
No,
boxes,
no.
I don't know
When I
which
did
box.
the test, I brought it. I brought mine.
Oh,
I'll bring it. Give me a minute.
you've got your special secret.
Well, I have the stuff for the test. So.
That's all the stuff that makes things work. Thank you, Marco.
ที่มันไม่มีในกล่องแน่นอน
Okay, so let's just.
Well, we have one.
Sorry?
Are we gonna get one out of the box
You sure?
I think we should ask for it, right?
or we need two
Sorry?
we need two one for transmit and one for receive right
Yeah, you need one for transmit, one for receive,
Yep.
and even for S-band as well.
Yep.
I don't think we forgot, but I don't know where it is.
in the box
I don't know which box.
I think I saw some.
Yeah. Well, no, here it was definitely. I saw one antenna with one cable
Mm.
with the antenna system,
Mhm.
but I need two anyway. So
Oh, okay.
it will definitely be with your
Yep.
setup because this will be attached to the outside of your box.
Mhm.
So you need the cable from the inside to this on the
Yep.
outside anyway. So I'm not too worried. Okay, so I've increased the current limit to 0.8 amps. And I switch it on. No current is flowing. I do not use the battery. I use the live switch. Now the satellite is on. The current is more than before. It was 0.8. Now it's a little bit more. Yeah. And you must now
Yeah,
talk to
I
the
can connect
OBC.
the SAMIs.
Okay. You must get our demo code
Okay.
running, please. Okay, it's working?
Okay. Yep.
Wow, you're so fast. It's a Mac.
Because it's Mac.
Because it's Mac. Okay, so on the same time, I must get my radio configured, right? So I expect to. I must transmit at 145.9. That's the uplink. So here I will talk AFSK 145.9. Okay. And the downlink is going to be at 436.5. And that is BPSK. 430.
36.5.
BPSK already. Okay, so now we're waiting for our cables. Yeah, I don't really. The radio is already on, so you can actually ask for telemetry from the T-Rex VU.
Yep.
Don't send commands to it yet because we don't want it to transmit. But what do you see if you ask telemetry from it?
You can get Toku Idol,
No.
before cosine.
No.
No. Get frame count, no.
Yes, get
Is
frame
it
count
true?
is good. And telemetry, the last ones is the important ones.
14 receives telemetry.
Yeah, so if you go to, there's a ref C, 14 and 15. Okay, what's the telemetry like?
Voltage.
Just say bus
7.
voltage, total current,
So that's the current
power
of the
amplifier, and temperature.
27 or 23,
20
sorry.
23.
Yeah,
Local oscillator temperature,
okay.
the Doppler and RSSI.
Okay, so this is your instruments. This is what you need to learn.
Is for the antenna?
Yeah.
I would say don't put the antenna because it will be too much. You're too close.
Okay.
Uh,
So just for a 10
yes,
right
yeah. Last week when we tested, I just put the wire in it enough.
Okay.
To place the wire because it is needed to at least have the wire.
But so I use this for a C for
Yeah.
Okay.
And this one you can actually just put the load in.
Perfect.
Yeah.
Thank you, Martin.
Yeah.
We will have to add this to the box.
Sorry.
We will have to add
Yeah,
something like
it's
this
fine.
to the box. They are very worried that we will ship it without anything in.
No, that will be so good.
Okay.
เล็กมากเลย
ชอบทำงานในที่แคบ
มันแค่
มันต้องรีบออกมาเสียก่อน
ไม่วันนั้นมัน
ถุง
โคม
ล
แค่
อย
สา
ๆ
ย
นี่มันลอยๆนี่นะ
เสียวมันทองพัง
มันจะผักจะหักวะ
มีออฟก่อนไง
หนูพาวเวอร์
เตือนเขาสิ
ก่อนแม่พี่ไลฟ์
ไม่มันยังไม่มีอะไรส่งออกมาไม่ส่งให้เราแต่มันแตกกว่าแล้วก็บอกผมส่งให้คุณเฮีย
ใช่
So Marcus said we didn't even need to add an antenna because we are so close. Fine. The good news is we have added the attenuator to the transmit port, and that is important because we don't want to cause interference. So yeah, you had to look at the telemetry.
15
The last two is maybe the most interesting ones. So the RSSI is giving you a measure of how strong is the uplink signal. If you see a high RSSI value and you are not sending something from your ground station, that means you are seeing noise. You're flying over the Russian radar or something, which is actually interesting. There are some satellites who has that as their payload. So if you have a satellite which monitors RSSI while it's flying across the Earth, and you capture data for a long time, you can actually draw a map of signal strength around the Earth. And that's a useful map to have
It is.
for various frequency bands.
It is.
For this one, it's a frequency of 145.6, but if you have a different frequency, you can learn a lot about the world. So yeah, that's RSSI. The Doppler telemetry is showing you if the uplink is off-center and if there is a Doppler shift involved in the uplink frequency. If the Doppler shift is 0, the satellite is directly overhead. If it's on its way from the horizon to overhead, it will be lower, the frequency will be lower, and if it's going down the other side, it will be higher. So that's that telemetry. The other is relatively simple. It's temperatures. The temperatures is very important. It shows you if the oscillators are going to be working as you expect them to, or if there's potentially a problem with one of the oscillators. This telemetry is quite good. It's actually looking quite well. Okay, so the next one, which is important for us, is the frame count. So there's a 7. That is frame count. Okay.
Currently 0 frames.
0. So there's no frame that's been sent from the ground and it's not received any frame. The way this works is the OBC looks at the frame count and he says, oh, there's a frame of data. I must get the data from the radio buffer. The moment he sees a frame there, he will go and get that data down, or not down, to the IOBC, and he will interpret it. If it's a valid command, the OBC must do something. And that is how the flight software should be interpreted. So if I send something to you now, I'm going to try and send a command at the right frequency, BPSK. Let's try. I sent something. Transmit is on, and now it's off. Read the frame count again.
0.
Still 0.
Yeah.
Okay. Then I'm not 100% sure why. This I would have expected to see something. I'm not 100% happy with the connector. Maybe I'm not making proper contact. Or maybe I should actually add an antenna. Okay, let me just try again. I'm also not sure what is the data rate of the uplink. It may be 9K6. I'm trying 1K2 at this
2
stage.
million.
อันนี้เฉพาะของพุตตี้
Okay. If you can just read it again quickly.
นี่น่าจะใช้ผ่านของบริ
Still there, okay?
change บิตเรทน่าจะ96
See if I try 9K6.
9600
What do you see?
No.
Nothing.
Nothing.
Okay, I actually don't only see.
You don't see. You check the ring. You don't see.
Yeah, but this is.
ดอกไอ้
Uplink.
Yeah, but the uplink,
ก็
that is downlink and that is uplink, so I
Yeah.
should change this one. You're right, I set the wrong one.
Do I need to toggle the idle state before?
No,
You know?
not. Idle state will do just now, that's the downlink.
EPSK.
Yeah, transmit.
มีมั้ย
Missing.
Still nothing? No, the uplink is this one.
uplink
And I'm sure I have to send AFSK. Now I'm transmitting, now it's done. Still nothing. Okay, I will get Marco to just help me with that. So what you should see is when you send a command, you should see a change in the number of frames received, and once you have that, the OBC knows he must go and get a frame. Okay, so the next one you can do is, what is there's a command frame as well?
yeah
Can you just check that one? No, that's just, if there was a frame, then that's how to get it from then you can read. If I send hello, you should see hello.
yeah
Okay, don't worry. But you can't do that before there's something in the frame. But we don't have something in the frame yet. Okay, so the next thing you can do is to actually toggle the idle state. So that what that does is it starts transmitting. So what we expect should happen is that we expect there to see a change in the current consumption. And what I expect to see here is if I go to my frequency, my FFT, I expect to see the flags. I should see a peak in the middle and I should see flags next to it.
So what is the toggle mode?
What it does is it activates the state of the transmitter. The idle state of the transmitter can be either on or off. So in this case, when you toggle it, it goes to idle state on, which means if you don't send data, it's transmitting. But you only send data with the other command. If you set downlink, if you send a command or send a frame,
there is no
well, default call sign send test number 3.
okay
That will send us one frame down. Okay, are you going? Okay, now you.
Yep.
So,
it's transmit
you just sent one frame.
yeah
There I see. But you've not toggled the idle mode now. You've basically started a little idle time, then you send data, and then you send idle again. So if I go to my receive terminal, if you do that again,
ถ้าไม่พูดไม่รับทานสมิตลอด
okay, I see a very strong signal, but I don't get data, and I think the reason is simply this. Okay, try again.
คือมันส่งตลอดไม่เกี่ยวท็อกเกอร์โหมดคือออนคือมันส่งอันนู้นจากซัตเทอร์ไลท์คือทานสมิต
Yeah, I don't see
ก็ไม่เกี่ยวกับ
data,
ท็อกเกอร์โหมดคือ
but it may be because I'm not linking. Okay, sorry, locking. Toggle the idle mode.
มันบอกว่าซัตเทอร์ไลท์ทานสมิต
So what you do now is you're transmitting all the time. So if you look at the current, it's high all the time. You're consuming 3 watts.
อันนี้ไม่ใช่ซัตเทอร์ไลท์นู้น
And
คือซัตเทอร์ไล
if
ท์
I look here, you can see
แล้วส่ง
Data.
what information
ของ
does
ซ้าย
it just setting the
อีฟส่งไป 9,600
โคไซด์
what was this?
แต่ดาวลิง
I changed it to 9,000
You shouldn't do that.
I shouldn't
Leave it at 9K6.
okay
Okay, now you see 9K6.
ไม่ใช่1200ไม่ใช่
เดี๋ยวตีเลย
1200ไม่ใช่
อีฟทำพังเหรอ
พังเลยไม่พังเป็นดีเลย์เฉยๆไม่พังเป็นอีกทีไม่พัง
รู้แล้วทำไมถึงต้อง
อะไรนะอิบทำงานก่อน
เป็นดีเลย์
อัดเสียงแล้วเนี่ย
Tuning, that's right. Okay.
เพราะเขาเห็นบิตเลยเปลี่ยนแปลงก็จะเห็นกราฟนาทีเราไปดูวิดีโอเราส่ง
That's right, that is right. But I should have a smaller. You see now there's a sync as well.
Yep.
That we didn't have before, and that's important. Otherwise, we can't get data down. If you send your toggle, of you send your call sign now.
again
I have a sync, but I don't get data. Are you you're sending it at 1K2, right? Still 1K2 all the time.
Yeah. 1K2.
Let me call a friend.
Oh, you have your own chatting software.
สแลก
22ไม่มีแล้วก็เลยรับไม่ได้เลยนะ
สแลก
I sit chip sending
มันเสร็จปุ๊บนะ
Slack off
สแลกค่ะ
Okay, I'll just wait for Marco to come, but basically what I expect to see now is that you send a frame and then I expect that frame counter to increase. I'm not 100% sure why that's. I do see he's going to be here in 5 minutes. So what I do see is when you send data, I see a change from frames to actual data. That is at least good news, and I do see a synchronize there, which is good. But I don't know why there's.
a little bit offset
Yeah, it's not.
1,200ป่ะ
frequency ผิดมัน offset อ่ะ
เขาใส่ 1,200ป่ะ
1,200
หรือว่าไม่ได้ใส่ด็อปเลอร์
ก็ใส่1,200ยิบ
ฮะ
1,200
So if you send the frame again.
436
ยิบความถี่อะไรอ่ะ
No, I still don't.
ความถี่มันเป็นเซนต์อะเซนต์มันก็เป็น
And
ดาว
if
ลิงอะ
you
438เมกะเฮิรตซ์
if you send it at 9K6,
9K6 okay
Yeah.
so I have to change the bit rate to 9K6 5 and send it send it
still don't
No?
think. But now I think my bandwidth is too big. I'm just making my bandwidth a bit less.
so ผมเปลี่ยนเป็น 9,600เขาบอกให้เปลี่ยนไหมครับ
แต่มันเปลี่ยนความถี่ได้ป่ะ
เปลี่ยนไม่ได้ อันนี้มัน
ของบูอีเท่าไหร่สี่
มันฟิกนะพี่
438เหรอ
Okay.
ของเขา436
เดี๋ยวนะผมดูก่อน
ยิบความถี่
เก
อะ
อ
ไร
ร์แป๊บนึงครับ
Yeah, still
อ๋อไม่ไอตัวนี้มันเปลี่ยนนะ
I only see
มัน
one.
ยังมีสแปร์
I only see the packets received that I've actually sent, which is I want to see your frames.
436.499
again
Mm-hmm.
I send it
Yeah, I see the change, but I don't decode it. I do see a sync, but I don't see a decoder.
get transmit
ยังมี
มันไม่บอก อันนี้มันไม่บอกความถี่รีซีฟที่ลองดูมันส่ง
คุณวิชาคุยเช็ค
รีซีฟมัน
This one?
get frame power
No, maybe. Okay, can you try again? BPSK, GCROH. Oh, you're right. Yeah, you're right. So what is done is there's a different
มีเวนซี่ฮะ
เป็นมา
there's a small difference in the way they encode the data.
SK ธรรมดา SK
So I
เป็น
added
BPSK
a normal BPSK, but there's a GCROH, which is another modem encoding around the data, and that's why I didn't
เขาเปลี่ยน
decode.
เป็น BPSK เหรอ
ใช่ที่แรกเราตั้งเป็น
So now you see your own ground
อ๋อ
station. Royal tile Airforce 0,
yeah
signal quite strong,
มาโคตรติด
you've been sending your call sign
yeah
all the time.
that's right
Perfect. Thank you very much. So you can tell Marco he doesn't need to come. Let's just quickly test it on the uplink as well. No, I think he still does need to come because I don't know
BPSK
which
อ๋อ
uplink
ของ
I
ASK
actually use.
ASK
The last time I think he used this one BPSK G3
This one?
yeah
Okay. Let's try. And I think it should be 1K2.
send
Okay, wait. I'm going to send it a few less times. Okay. I'm transmitting. What do you see in your frame?
Nope.
Still nothing.
Bit, you send at what bit rate?
1K2.
1K2.
Yeah, but the sync is further down. So the uplink, the sync must be on this side.
Can you send it?
I can. It's not difficult to do. Still nothing. Hey Marco. I'm used to the old TRX UV.
Okay.
So with their help now.
Yeah.
What should the uplink
Also,
be?
this one you have the whole. I'm guessing that you have. Yeah, that's because you have the whole installation. It's fine. And here is always FSK, eh?
AFSK.
Yeah.
I had it there.
Yeah.
And then when we sent, I sent hello 5 times, but there is no change in the frame count on this side.
Okay. You're a bit close.
Oh, I'm shouting too loud.
Yes. Let's try again. Scale. Yeah, it's 1K2.
1K2 is always,
But it doesn't need it.
The downlink starts at 1K2. I don't know if you remember when we were seeing it that you can actually change the bit rate. So the default is 1K2. But then you can go to 9K6. He has a command that he can play with 1K2 and 9K6.
Yeah. We've changed that now and we've seen the effect of changing it, so that's fine. We just didn't manage to get the uplink to
To
it.
get it up. Okay. You can send a couple of times just to see.
Yeah, it's transmitting. Still nothing.
I would say. As we have it before.
Now you shout louder again.
Yes, but it's not close. It's fine. The distance is fine. It's connected, right? Yeah, it's fine. Yeah. Received.
Okay.
You forgot.
Don't worry for the computer. It's fine.
No, but they've been trained. You touch my laptop without the glove.
Yeah, I think because the thing is that well, you're not putting antenna there, but
Then you should put it there.
you should put it here.
Okay. Okay. No problem.
That's it.
That's it. Thank you very much. I will call you again when we get the S-band.
Okay. You have already the S-band, by the way?
It is here. Everything is here, but we will just do
Did you have the installation also?
because I didn't need it. So maybe you should.
I have it already, but I had issues with their computer. The problem is that
This is why I use mine.
yeah, I want to see if we can test maybe put one with the inverter with their at least the one that has.
แล้ว thank you
And now send your call sign. Okay. Did that go through now? Are you doing it at 9K6 or 1K2?
1K2.
1K2. Sorry, let me just get ready for you. This was what the picture looks like at. There you go. Now I'm receiving. Okay, so there's the Royal Tail Air Force. This is very boring to do it over this distance, but if you receive this image or this data in your ground station with 500 or 2,000 kilometers to your satellite, you will be very excited. Then it's really a wonderful thing to see. Okay. Thank you very much. So you can switch off, toggle your idle state. So that should be good.
มันเป็นเครื่องอะไรพี่มันเป็นเครื่องอะไร
The box of the radio. So the TXS is this one.
The one is a TXS and one is the checkout. That's the checkout.
Yeah, but the radio is this one.
Yes. What do you need?
Do you have the frequency? I think it's this 2204, but okay. Let's try it. But I think it's. I'm almost sure it's this one. But
Otherwise, you may have to look on the.
it's there.
No, the TRX VU has got its test report with it, but not this guy.
Okay. But
Sorry, I don't know. I don't know it by heart.
I think it's 2204. It's fine.
Okay.
น้อยยิบทำอะไรอ่ะ
กำลังจะส่ง
ไม่ทำไมไม่มีคอมพิวเตอร์ไง
So I'm going
ก็มี
the power supply is switched
อ๋อ
on.
นี่หายไป
The live switch is now switched on. Current did increase a little bit. You see it? And that is because we have added another component, another 40 milliamps or so. So can you talk to our OBC?
Okay. Let's try.
It's becoming to look like a satellite.
Looks nice.
I don't know. I like it more square.
Yeah. Okay. Number 6.
Then you start sending data.
Then it won't send data. It will be just sending flags.
Yeah, it's consuming current now.
Okay. But I just want to see on the 50.
Okay, so if you've been checking the current consumption, this is a new record for us. We've been using our record previously was 3.7 watts, and now we're at 4.7 watts. This is the most current we've consumed up to now. This is the highest current consumption device. We may beat it when we get to the ADCS, but for now this is our biggest current. So are you seeing something?
The whole point is that you can actually go faster. So that will be the default, and then based on that, then you can actually go like half, and then a quarter, and then an eighth. So you start by an eighth because it's the slowest way, but you can always go to 115 K2.
You start with the slowest because that's the best signal to noise ratio that you can get. That's the best best chance that you have of getting a lock in the ground station.
Yeah, I think that's also important to have in mind for the TTNC radio, which is the TRXVU. You also, again, you have the option from 1K2 to 9K6, and most people, because they think, okay, it's just faster, let's just go to 9K6. But it's important to have in mind that, as he said, like if you start with a slower bit rate, then the link would be better. So you usually start with that, and then when you're sure that your link is good, then you start going faster.
Have question. So this is in a normal operate. What module rate level that we
The attenuation.
I saw here.
Yeah, attenuation, I think, I mean, for our case, for flight, it's only if you want to play with just a link. But I would say that, yeah, at the beginning, you just go to the full power. If you want to just, kind of play with the link, and because the whole idea is that you can reduce the power, the power consumption, of course, of the radio by reducing the power output.
Yep.
So if you reduce the power output, you can at least reduce a little bit the consumption of the radio itself. But I will say, again, you need to first, as flight, you need to start first with the best link, and then see if you can reduce that.
There's two reasons. The one is to not cause interference to other frequency users.
Yes, that's right.
If you have a very big antenna on the ground, and you get data down well, you can try and reduce the current, the power eventually, to have your batteries work longer. But if you are struggling to get the data down, you just want your data, you want your image.
Yeah.
So if you increase the attenuation, what you will effectively do is, if you think of a photograph, you will generate noise in the photograph. You will start losing lock, you will start struggling to decode the image. First priority, get the image, and then worry about the other frequency users or the battery.
Yes, correct.
It's because if you are paying for the image, then you're the image engineer. You don't care about this battery and this ABC. That's not important. Just the image is important. If you're the power engineer, then power is everything. You want to save the battery. So I may be that guy.
You want your mission also to go
Yes, a few years. Yeah.
longer. So yeah.
Okay, so this is the TXS, demonstration of TXS. And the photodiode. You can see the photodiode there.
Photodiode.
Yeah.
Is there?
Let me take it out then, it's easier to see. Okay. So that blue device there is the photodiode.
Blue.
Oh, sorry, I'm lying. Sorry. That is the temperature sensor. The photodiode is protected underneath this piece of.
Yes.
That is the photodiode.
Is a blue.
That one is the photodiode, and that's the temperature sensor.
Oh, okay.
So you see the photodiode has got a connection at the bottom, and there's a wire soldered on top of it. That is its two connections, cathode and anode connection.
เป็นข้อสองข้อข้อห้า
So yeah, this is the first bit of very sensitive electronics. That photodiode is a small piece of glass. It's sensitive, protected with a small piece of tape over it. But of course, your solar panels is only half of this. You've got 6 of these, and on the other side they are connected to the daughter board of the IOBC, which plugs into that connector. But you also have power. So in your engineering model, you've got 3 power solar panels. They are interfacing to the power system, the EPS, with connector. And on the other side, this is the power connector that's going to the solar panel itself. You see the 6 connectors. You panels, which means you connect one, skip one, connect one, skip one, till you've used up 3 of the regulators. Then you can test 3 regulators at the same time.
You mean one panel and
Yeah, one panel, one regulator, one panel, one regulator. Because then you can actually look at the current and you can see current on all 3 regulator inputs. I don't know, you can define it various ways, but that's how I would do it. Okay, that's harness engineering in practice. And this is the solar panels. So you've got 3 of these. It's actually a 1U solar panel. So a 1U in our case is typically got 2 cells. And then on the other side we made provision for the same sensors. So if you look closely there, you can actually see a photodiode as well.
oh photodiode.
Yes, because this is not a
Did you have another temperature on?
no.
No.
No, this was there because this was mass produced. This is actually a flight solar panel, and it was meant to be used on a 1U satellite. So it's not a toy. It's really a solar panel. And when we have a 1U satellite, you want the same sensors, but we then wire them in those holes. But for this panel, we are only going to use the power side of it, and this is this guy. Okay.
This cable is the same that cable.
Yes. Yes. You can connect the two together.
Like we have 6 of the solar panel like this. The
You've
flight
got
models.
6 sensors.
6 sensors.
Yes. And you've got 3 power.
3 powers.
Yes.
And how many panels do we have?
Oh, for your engineering model,
Yeah.
you've got a panel on all 6 sides.
All 6 sides.
But 3 of those sites will have photodiodes. Photo cells.
Photo cells.
Yeah,
Okay.
photovoltaic cells attached to it. But this is a 1U panel. It's meant to fly. It's got protection diodes on it. We've built it ourselves. And
Okay.
it's the brother of some that is flown. This is a Perspex protection. So you can get this thing in there and you can break the glass, but we try and make it difficult.
Good.
Yeah.
Could you show me?
No. I don't want to.
ตอนที่เขียนไปไม่ได้
It
ใส่โมเดล
it mean one panel have one piece
ก็เลยไม่เอา
to sell for
จริงแต่มันให้
then
จริงก็
total either we have three panel
3 panels
work for
with the
three panel
photodiode.
and 6 cell.
Yes.
Yeah.
EM เราไปตัดแดด
That's right. 6 in total.
ให้ตักแดดก็คือเป็นมันแบ่งเกรด
มีแผ่นไหมครับ
มีthree panels
So this is just more of the same.
Yeah.
so we got 3 of them so
You've got 3 of these guys. This is more of a, I don't know, maybe a test, something that you can use to verify the power. This is interesting if you connect it to a multimeter And you shine light on it. You can draw the graphs that I've shown you in the presentation. You can verify that the system is actually working. So it's not something we don't normally supply this with engineering models.
True.
But for you, I think it's a good thing to add it. It's a wise thing to add it because you can actually start experimenting.
I didn't see that in the option of the engineering model.
Oh, okay. Well, I think we normally,
มียาง
when I say engineering model, I'm used to smaller ones, 1 use or 2 use or 3 use. I don't think I've worked on a 6U before. The biggest one I've worked on was an 8U, but that was
We want to impress our boss. That's why we go for 6U.
that you should do.
For the final,
คิวบิก
can we show you power
แต่ว่ามีโซลาร์แผงด้านข้างต่าง
power
มันใช้
theoretically
ร่วมกันได้
Well, if you think of the final, then you will have much more cells, of course. On the big sites, you will have, I don't know how many cells, but 10, 12 cells.
1 2 3
You make a big
5
side panel with a lot of power.
ก็
in
ไม่
in
จะ
the
มาดูว่า
พอเสร็จแล้วอ่ะคือเราเทเราปุ๊บเอาไฟฉายส่องแล้วให้มันโชว์
วัด power
โชว์นาย
Oh,
ฝั่งไหน
he mentions that like at the end of
มีหกด้านไหมอ่ะ
the project,
4
like,
5 6 อ่ะ
this one here attached to the size of the satellite, the EM satellite, and then he just put shine the lights on it, and then
Yes.
see like whether
Yes.
like it generates
Yes,
power.
yes. So you look at the telemetry from the IOBC.
มันใช้ทำอะไรบ้าง
We had 300 millivolts or something on the telemetry from the IOBC earlier today.
Okay.
And when you shine a nice strong light on this, you should see 3 volts.
Okay.
Yeah. So you should see quite a substantial difference.
Okay.
Even now, if I put a multimeter between those pins, I should see
Some current.
current
If I don't load it, I will see a high voltage. But if there's a faint light, this is actually quite a faint light, and I put a load, the voltage will drop. So there's a relationship between voltage and current, which is characteristic for the solar panel.
so for the CubeSat one we have like 5 of this one for flight model right
For flight model, you will probably have 6.
6
You will have cells on all sides. So we also have a special configuration where we add this to the top of our antenna system.
and you have a photo sensor 6
6 at least, yeah. 1 per side. So this you will have exactly the same. But
it
they-
can help the attitude determination system
Yes, indeed, it's used for that.
okay
So the one thing is the attitude determination to see where is the sun or how is the satellite orientated. The other thing is temperature, which is useful for the same reason for attitude determination and also for the thermal control. If you know what is the temperature on the extremities, then you can calculate what is the temperature on the inside. Yeah. Typically the temperatures on the solar panels are the highest and the coldest. Minus 40 plus 60 easy, and then you have 20 or 15 inside.
what if we install the GPS the one we're missing right
Not really. Well,
I mean if we install the GPS and it have to be on top of the solar panel or
that's not a good idea. No, you won't. They will be. Your solar panels will be designed with some areas where we make a hole for the camera, or we leave an area open for the GPS antenna, for instance. That's exactly why the solar panels is such an expensive thing. They have to be custom made for every configuration. Okay, but this is just a demonstration. This is just a 1U, just to give you an idea.
แล้วเราส่งเสียงแล้วก็ดึง
จริงไหมเนี่ยโชว์นาย
จริงว่า
ก็
มีคิว
มันจะได้แบบเฮ้ยมึงจะได้อะไรมามั่ง
จริงเนี่ยไม่เชื่อ